Hello, in this video I'm going to talk about the Sinclair Spectrum 48K. This was a popular computer in the 80s and I had one myself. Specifically, I'm going to talk about the Horizon software starter pack that came with the computer. A few years later, there was another software tape called Beyond Horizons, but I'm just going to stick to Horizons for now. Please remember to like and subscribe to my channel for more interesting videos about computer science and software engineering. And yes, I did say tape, as in audio recording tape. So these tapes would fit into a tape recorder or tape player, and then you would play music, or in our case we would load our games and even save our games to a tape. Our tapes with our software and games on would be played on a recorder, a tape recorder. Sometimes the tape would unravel and come out of its casing. This was a real disaster and you had to be very careful about putting it back in again. Here I have a copy of Spectrum Horizons, and this was some software that came with the Spectrum 48K and gave you some instructions on how to use it. We'd have to use a tape to load things in to the Spectrum. All software was stored on a tape. If I get this started and we go through side A, because that's why it's got side A, you'll see there it's got side A and there is side B. We're going to look at side A. Set the volume correctly, please wait. That's basically what that is about. That is about making sure that the tape recorder is actually outputting at the right sound, and you had leads that went from the tape recorder into the back of the Spectrum. Now this is the little training program that it had. So once it got started, you would see stop the tape. So you would stop the tape and then have a look and see what was going on here. So we don't have to stop a tape, obviously, so I can just push any key. So this is basically what we had, and this program is just to introduce us to the different aspects of the computer. So we have the ROM, the RAM, the Z80 CPU, and the ULA. We have, like, well, if I just run a program, it explains it to you. So here it's saying that the most complex is the CPU, and yet it was the cheapest part of the computer. And nowadays CPUs can be very expensive. The CPU is obviously not much use without the ROM and the RAM. So the RAM is the read-only memory and the RAM is the random access memory. And remember that RAM is volatile and ROM is going to be holding different kinds of programs. See, so here we can see the ROM contains fixed programs and data which allows the Spectrum to start working as soon as it is switched on. So your computer would have the same kind of setup, really. You know, it's going to have a ROM and a RAM and a way of setting up the computer when you switch it on. This is just basically explaining that information can be held in RAM, but as soon as you switch it off, it's lost. That's what I mean by it's volatile. So now it's discussing the peripherals, and we would need to plug our um, our spectrum into a TV set, and this would be an old-fashioned TV set with it was basically like a box, a big box. Um, the television would have its own speakers usually, and the tape there that we can see this. I don't know if you can see that. The tape um, would be where we would have the games and stuff, and that was basically how we would store a game. So it's saying that you can attach other peripherals um, via the edge connector. You can see the edge connector is flashing away up there. The edge connector was basically an interface at the back of the spectrum that you could plug in your joystick interface, for instance. I had a Kempston joystick interface. You could get other types of interface, and they all worked fine. You know, there was Kempston joysticks, Kempston interfaces. You know, there was quite an industry around it. You could add a printer, which was kind of handy. So the ULA is a custom designed chip, and that would handle stuff between the peripherals. So this is just a demonstration of the sound quality. It's amazing, isn't it? But it was fantastic at the time. We had nothing like it. Here is explaining about the tape recorder, and as I said before, you'd have to plug these leads that would go from input and output to the input and the output at the back of the computer. This is explaining that we need a keyboard, and although the keyboard was a QWERTY keyboard, if I just look up here, if you go to, because I'm running this in Fuse, so if you go to Help, you'll find the keyboard there, and this was the keyboard that we had. So if I just make that a bit bigger so it's easier to see, this was the keyboard that we had, and it was on top of the Spectrum, and you can see that there's all of these different functions on there. We'd have to learn how to use these. So cap shift, that's obviously pretty sort of straightforward. Break, that would interrupt program. Enter, that's familiar. Print, poke, that we used to use that for like putting in cheats and stuff halfway through a game loading. So we have these functions, these commands. So if you think about it, if you've got something like load, and then you put in like simple shift quote quote, you would load, then start the tape and load in your game. So load there is its own own function. So it was quite a complicated keyboard, and you had to learn how to use it. So what comes next? is a bunch of tutorials on how to use the keyboard. So if you say no, you don't want to run the program again, it then asks you to start the tape again, and then stop the tape once it would load it, because it would be loading, and then you would be asked to stop the tape. You would get this, and then you would have like an instruction on what else to do. Right, so it said do not press break, because if you did, it would interrupt the program and you'd be able to have a look at the source code. Press E to continue. I'm not going to bore you with, like, all of the lessons that it had on this, but lesson 1, typewriter mode, lesson 2, single entry of words, lesson 3, the cursor mode, and extended mode. These were all different aspects of the keyboard. So if I click on side B, and it opens up automatically, and it's like, okay, stop the tape. And now we press any key and we see what happens now. And we've got Through the Wall, which is a game, Bubble Sort. Oh, that's kind of interesting, isn't it? Evolution, life, draw, and there's various other aspects to do here. So if I do Breakthrough, let's go through Breakthrough and have a little look. So this just tells us about the game. Flight simulations, chess, Hungry Horace. That was quite a popular game, actually.
It's 2:00.
So go P to move right, and O to move left. Oh, and cap shifts for extra zip. Right, okay. Right. So this was one of the games that came with the Spectrum to get you going. Oops. Right. So that's enough of that, isn't it? How do we end this? Right, let's do no. Bubble Sort. Right, now this is quite interesting. What is Bubble Sort? Bubble Sort is a simple algorithm for ordering a list of items. The algorithm passed over the list, comparing neighboring items, and swap them if they are out of order. Repeat these passes until the list is ordered. The following page illustrates a single pass of this algorithm applied to a very simple list consisting of 4 numbers. The objective is to place the list in ascending order from left to right. Press any key. Okay, so if you've done computer science, if you're interested in computer science or computing at all, you've heard of Bubble Sort, and you know what this is. And here it's going to show you how to do that. Compare 6 and 3. Swap yes or no. So is 6 greater than 3? Yes. Is 6 greater than 8? No. After the first pass, the largest number has bubbled to the end. Another 2 passes would complete the sort proceeding 2, 3, 6, 8. Press any key. This right, okay, to speed up the sorting, hold down any key. Right, okay, let's have a look at that. Let's see what it does. And it's going to pass through. And here's one pass. And here's two passes. Three. And we can see that now the cards have been sorted into orders depending upon what suit they are. And it's going from largest to smallest. Foxes and rabbits. This would be the next program. If you're familiar with maths, you'll recognize some of these symbols and you know what's going on here. So let's have a little look. As the foxes decrease in numbers, the rabbits begin to increase. So here we are at draw. There are two cross wires, and yeah, this is just some instructions on how to do the drawing. So this plus sign is moved by pressing the arrow keys, because the arrow keys on the arrow keys on the keyboard are going to be at the top here: 5, 6, 7, and 8. So let's just shrink that down a bit. And we can move this X1 by using shifters at that -5, 6, 7, or 8. That's kind of strange. Let's see what happens. L draws a line, C draws a circle, B draws a box, and Q gets you out of the program. So if we enter a color, what color is this? Enter a color for the ink. Let's do 5. See what happens there. Right, so press I for instructions. See how really slow this is. So if I press out now, I would get a line. Was it C for a circle? There we go. Do you want to paint this? Let's do yes, see what happens. What color? Well, I want to go for 1 because I want to see what that is. And now it's painted the circle there. I for instructions. Well, draws a box. So this is the kind of thing that we had to entertain us, and it was well, difficult. Yes, you can see that it was quite difficult, but also it was amazing because we could see that you could type code in and that you could get a picture. You could type coding and things would change. and we were getting examples of programs and then being encouraged through magazines to try and improve programs and to think like a coder. That's both sides of Horizon and the end of this video. I really hope you liked my video. If you did, give it a thumbs up and come and check out my channel.